Dear learners, welcome to ARPIT in Library and Information Science at IIT Delhi. Our today's topic is Scientometrics and Altmetrics, Trends and Issues. Now, in the context of Library and Information Science, we know there are several terms containing metrics are in practice. Those are Librametrics, Bibliometrics, Scientometrics, Informatics and Webometrics. These terms are listed here in chronological order. Now, areas of special application of statistical tools and techniques to various disciplines have given new names also, such as econometrics, sociometrics and informatics, etc. Now, any subject containing metrics is actually application of statistical tools and techniques. Therefore, bibliometrics is the application of statistical tools and techniques in library and information systems and services. Now, any system of measurement invariably involves one crack subject from methodological viewpoint, that is statistics. Now, Professor P.C. Mahalanobis, known as father of statistics in India, started statistical research in India in early 1950s. As statistics demands systematization and organization of data, similarly library and information science demands organization of knowledge. Now, let us say the terms one by one. For instance, the term informatics was coined by Blackard, Siegel and Otto Nack in 1979. And informatics is the study of the quantitative aspects of information in any form. Also, the quantitative studies in library and information systems and services at different time period were popular by various names. For instance, statistical bibliography in early 1920s, Librametry in 1940s, bibliometrics was in late 1960s, Scientometrics is after 1960s and the term informatics came after 1980s. Leo Ege and Ronald Rousseau have identified a place for informatics among other fields. For instance, mathematics, and in the mathematics they identified several domains, for instance operational research, probability theory and discrete mathematics, which eventually shaped into the practice of informatics, and that can be applied in different domains of library management. Nowadays, many other cousin terms also exist. For instance, besides Scientometrics or bibliometrics, there is patentometrics, blogometrics, newsmetrics, cybermetrics, wikimetrics, open source metrics, what not and so on. Now, bibliometrics, this term was coined by Pritchard in 1969. According to him, bibliometrics means the application of mathematics and statistical methods to books and other communication media. Bibliometric studies are mainly employed to investigate the following areas, that is scattering of articles, author productivity, citation study and measures of journal productivity. The next, Scientometrics. This term was coined in 1969 by Vasily Nalivov and Z. M. Muchlenko. According to Van Rand, Scientometrics is defined as the quantitative study of science and technology. Scientometric studies are mainly applied for the following topics, that is history of science, growth of science and scientific institutions, behavior of science and scientists, and science policy and decision indicator. Now, Almind and Ingerson coined the term webometrics, which consist of the following core areas: web page content analysis, web link structure analysis, web usage analysis including log files of user search and browsing behavior, and web terminology analysis including search engine performance. Now, this graphics indicates the relationship between different metrics. It was introduced by Thelwall, Vaughan and Giornoboren in 2005. Here we are seeing the informatics is the major set and bibliometrics is the subset under it, Scientometrics is still subset and overlapping areas are there. Actually, so the relationship between different metric terms are well understandable from the set approach. Now, the field of informatics embracing the overlapping field of bibliometrics and scientometrics. Webometrics is seen as entirely encompassed by bibliometrics, because web documents in their various forms such as text, multimedia are all recorded information stored on the web server. Webometrics is partially covered by scientometrics, because many scholarly activities today are web based, and cybermetrics completely covers webometrics, but exceeds the boundaries of bibliometrics, because some activities in the cyberspace are not normally recorded. I. K. Ravichandra Rao stated that the research areas of following topics are called as bibliometry, or as scientometrics, or as bibliometrics, or as informatics. That is, quantitative aspects of LIS, quantitative studies relative to book usage, acquisition, age distribution of documents, citation studies, analysis, journal productivity, author productivity, obsolescence and growth studies, quantitative analysis of science, identifying relations among various disciplines, structure of subjects and disciplines, evaluation of scientific research by institutions, individuals, or by countries. Now, bibliometric approach. The concept of metrics was originated from here. S. C. Bradford and A. J. Lotka, known as father of bibliometric approach. Derek D. Sola Price generalized different bibliometric laws, and Eugene Garfield shows the applications of bibliometric laws. Actually, Derek D. Sola Price 1922 to 83, he was a physicist and historian of science, and he is known as the father of scientometrics. Actually, the theoretical foundation of scientometrics was developed by D. Sola Price. He estimated the number of the scholarly periodical titles being published by the end of 20th century would exceed 1 million, and his masterpiece Little Science, Big Science and Beyond very picturesquely depicts the difference in science research in the pre-Second World War and post-Second World War era. Eugene Garfield, who is known as the father of practical bibliometrics and scientometrics, 1925 to 2017, he is the father of citation indexing, founder of Institute of Science Information in 1964, and he later formed Social Science Citation Index and also Arts and Humanities Citation Index. All these are included in Web of Knowledge today. Now, classical indicator approach. Actually, today the practical bibliometrics or scientometrics may be divided or categorized in two different eras. First one is classical indicator approach and the next one is modern indicator approach. In classical indicator approach, the first indicator was impact factor, journal impact factor. It may be also author impact factor, institution impact factor, or country impact factor. It was introduced by Eugene Garfield, and it is defined as C1 plus C2 divided by x1 plus x2, where x1 plus x2 are the number of articles published in a journal in 2 years, y1 and y2, and C1 and C2 are number of citations received by all those publications in the current year. So, here if current year is 2019, then x1 is the number of articles published in 2017 and x2 is the number of articles published in the same journal in 2018, and C1 is the number of citations received by x1 articles in 2019 and C2 is the number of citations received by x2 number of articles in 2019. Therefore, the numerator contains citation and the denominator contains number of articles. So, it is the ratio between citation to number of article. Hence, if citation exceeds article, that means more impact. So, impact factor greater than 1 indicates more impact and impact factor less than 1 indicates little impact. Next, immediacy index. Immediacy index means C by x. This is current year's indicator. For instance, here x is the number of articles published in a journal in the year 2019, and C is the number of citations received by X articles in the same year. Next, cited half life and citing half life. Now, cited half life is the number of, this is actually age, the number of citations received by all articles, and the number of years which accounts for the 50% of the total citation, that is cited half life, and for source item this being citing half life. Next, modern indicator approach. Now, this diagram is the basic diagram of modern indicator approach. Actually, modern indicator approach dates back to the year 2005 by the physicist Hirschfelder, who introduced the concept of H index. It is a 2-axis indicator. For instance, here in the diagram, x axis indicates the publication rank and the y axis indicates the citation number. Now, let us see x axis, which indicates rank of publication, y axis citation number. So, if we plot by publication versus citation, we will get this rectangular hyperbolic curve, of which what is H index? This is the number of citations received by top H papers that receives at least H citation, that is, and this is H squares, and this area is known as H core citation, this area. So, H index we have seen, but one important point is that H index is not a complete indicator, it is an incomplete indicator. Why? Because here the mathematical formula of H index is given, that is E square equal to C j minus H, where C j is the total number of citations, summation over j equal to 1 to H equal to C I minus H square, and E index, E square indicates excess citations. Here C j are the citations received by the jth paper and E square denotes the excess citations within the H core. Now, assuming d square equal to C j, it is obtained d square equal to E square plus H square. Here E greater than equal to 0 and E is a real number, that is E is equal to root d square minus H square. So, E index, larger the E, the larger the net excess citations, and higher the loss of citation, the smaller the E, the more reliable the H index. Therefore, H index is more reliable if the value of E index is small. For larger E index, the value of H index accounts large number of loss of citations. Now, replacing the summation of equation 1 by integration, actually for very large number of discrete variables, assuming it continuous one, the summation can be replaced by integration, assuming the citation function C j as the continuous dependent function of time. When we assume citation as discrete function, truly it is discrete function, but for very large number approximating it as a continuous function, we get this equation 5, that is E square equal to integration limit 0 to h c function of time minus h of dt, or E square equal to c t dt minus h square. So, we have seen what is citation loss. It is associated with excess citation, that is E index, and citation fall, this is associated with low citation. Now, an arbitrary point in H E plane represents the overall information of citations received by all papers in the H core. It is interesting to point out that the Euclidean distance between the origin and the point P H E is equal to r is equal to h square plus e square to the power half, that is root equal to d. Let us say this quantity as d. Thus, R index, another indicator, it indicates state of citations of all papers in H core. Now, rewriting equation 3, it is found d square equal to h square plus e square equal to h into h plus e square by h equal to r square. Now, we can replace h plus e square by h by a. Why replacing? Because we want to show that d square is a multiple of h index for that, and the multiple factor is the h plus e square by h, and it is defined as another index, that is a index. So, a index is nothing, it is the ratio between r index and h index. Therefore, 4 indices are obtained here, h index, e index, a index and r index, and these 4 indices can be divided into 2 types, fundamental and derived indices. A fundamental index is an independent variable and can be used to derive other indices. Here h index and e index are fundamental indices since they are independent of each other, whereas a and r indices are derived indices that are calculated from h and e index. Now, h index ignores excess citation causing loss of citation information, and to overcome this limitation of h index, Leo Eghe in 2006 proposed another index, that is G index, that is considered as an alternative for the H index. Let us now explain the E index and excess citation diagrammatically. Say this is x axis, it indicates ranked publication, and y axis it indicates citation. Now, the plotting of citation versus publication yields this rectangular hyperbolic curve, and this square indicates H core citations, and this zone is known as excess citation. Let us say this zone as E and this zone as T. Here E indicates excess citation zone and T indicate tail citation zone. Now, E actually indicates H core excess citation, and summing E and T will give you total excess citation. Hence, excess citation may be of 2 types, H core excess citation and tail citation, and the ratio between excess citation and tail citation is very important, particularly in the context of Indian journals, because if for any field very large number of articles are either monocited or dicited or tricited, in those cases tail citation is very important thing. And H core citation, say it H, it indicates the minimum required citation, define H index as the value H. Hence, this is H core excess citation and tail citation. Next, let us see the importance of R index. Now, in the previous paper we showed 2 axes, citation versus publication axis. So, this space, this is citation publication space, this space defines H index and E index. Now, if we draw another plane, say along x axis, let us plot H index, along y axis let us plot E index, then this graph will describe a H E plane. And it is another important assignment to find out the locus of any article or of any journal in the H E plane over the years. If that can be done, then the research front of any particular subject domain may be clearly identified. Now, what is it? Say for any journal or institution, whatever it may be, high H index and low E index. We can define this space in 4 equal zones. Zone 1, where both H index and E index are high, high H, high E. Zone 2, low H, high E. Zone 3, here both are high, here low H, high E. Zone 3, low H, low E, and zone 4, high H, low E. Now, the articles residing in zone 1 are important, it is very limited, and from this classification we will be able to find out, this is H axis, this is E axis, the coordinate of any article over the years. Suppose an article has this type of coordinates, another article may be this type of coordinate, another may be this. Joining all the lines, we will get how research in any particular field advances over the years, and from H E coordinate, H E plane, we will be able to determine the different zones in which the H indices and E indices, the values are included. So, we have seen H index ignores excess citation causing loss of citation information, and to overcome this limitation of H index, Leo Ege proposed another index in 2006, that is G index, that is considered as an alternative for H index. The G index does not average the numbers of citations. It allows citations from higher cited papers to be used to reinforce lower cited papers in meeting this threshold. Actually, the important thing is G index includes lower cited papers, but only above the threshold. Therefore, G index does not include the papers residing in tail zone. We have seen this is the tail zone. G index does not incorporate the papers remaining within this space. This is the formula of G index, G square less than equal to summation C I less than G, where C I indicates the total number of citations received by top cited, I number of articles. So, H index may be holistically interpreted by E index, also G index is significant. The picture of H and E index becomes complete after inclusion of R and A index. So, this is the, we have covered the modern metrics. Besides H and H related indices, there are other indicators, that is journal level metrics, classical metrics we have already defined, impact factor, immediacy index and half life. There are SJR, that is Simago journal ranking introduced by Scopus, and SNIP, source normalized impact factor. There are author level metrics, that is citations per paper, H index, G index, okay, I-10 index is there, number of articles received 10 or more than that citation, E index, R index, A index we have already covered. And then article level metrics, we will come to that, that is citation mention, view, share, download, bookmark, impact story, blog code, etc. Alt plus metrics equal to altmetrics, actually alternative metrics. Hence, the age of citation related metrics, the modern citation related metrics started in 2005, and another paradigm shift occurred in the year 2011, when the concept of alternative metrics was introduced. Now, altmetrics, it actually includes the different parameters which appear through the social networking, educational and research networking sites. And the factors which altmetrics include are, for instance, viewed, which includes HTML views and PDF downloads, discussed, that is journal comments, science blogs, Wikipedia, Twitter, Facebook and other social media. Saved, Mendeley, CiteYouLike and other social bookmarks. Cited, citations in the scholarly literature tracked by Web of Science, Scopus, cross-reference and others. Recommended, for example, used by F1000 prime. This is the screenshot of altmetrics.org. This is very important site, altmetrics.com also. Now, Altmetrics Manifesto, it actually expresses the basic objectives of Altmetrics. It was released on 26th October 2010. It says, no one can read everything. We rely on filters to make sense of the scholarly literature, but the narrow traditional filters are being swamped. However, the growth of new online scholarly tools allows us to make new filters. These altmetrics reflect the broad, rapid impact of scholarship in this burgeoning ecosystem. We call for more tools and research based on altmetrics. And there are numbers of major altmetrics tools, and it has also limitations, and the major limitation is the first, at the first point it is mentioned, it works only when DOI is available, the digital object identifier, and in most of the Indian journals and Indian articles DOIs are not available. For instance, in most of the previous 2000 published Indian articles in Indian sources, hardly 0.5% DOI are observed, and in several databases such as PubMed and Archive, it works when publishers embed Google Scholar friendly citation metadata, that is one limitation. So, it is dominated by Google Scholar. Twitter mentions are only available for articles published since 2011. Prior to that are not included. Some major altmetric tools let us discuss. Number 1, Impact Story. Now, Impact Story is a web based application that makes it easy to track the impact of a wide range of research artifacts such as papers, data sets, slides, research code. The system aggregates impact data from many sources, from Mendeley to GitHub to Twitter and more, and displays it in a single permalinked report. Next, Reader Meter. Now, Reader Meter is a mashup visualizing author level and article level statistics based on the consumption of scientific content by a large population of readers. Readership data is obtained via the Mendeley API. Reports are available both as HTML and in a machine readable version as JSON, and they are released under a CC by SA3 license. Science Card, it is a website that automatically collects meters means citation download counts altmetrics for a particular researcher. All the researcher has to do is provide a unique author identifier such as author claim or Microsoft Academic Search ID. The Plows Impact Explorer, it allows us to browse the conversations collected by altmetric.com for papers published by the Public Library of Science, Plows, and Paper Critic, which offers researchers a way of monitoring of types of feedback about their scientific work, as well as allows everyone to easily review the work of others in a fully open and transparent environment. And next, Crowdometer. It is a web service that displays tweets linking to scientific articles and allows users to add semantic information. Crowdometer uses a subset of the citation typing ontology and ontology for the characterization of citations both factually and rhetorically. The results of this crowdsourcing effort are displayed in real time. Now, the links below will allow to connect with both Altmetrics users and individuals interested in subject. For instance, Altmetrics on Twitter, a great deal of discussion about Altmetric takes place on Twitter through the use of the Altmetric hashtag. Altmetric.org, this website serves as a hub for much of the activity surrounding Altmetrics. Though their list of tools and communities do not seem to have been updated recently, their listing of events is updated consistently. Mendeley Altmetrics group. From the group's description, the aim of this group is to discuss new approaches to the assessment of scholarly impact based on new metrics. One point to remember that is important, that the Altmetrics area has been introduced recently, even less than a decade. Hence, it is still under experimentation, but the introduction of H and H related indices, it forms the basic analytical framework. Therefore, the different altmetric indicators we have discussed, that also needs to be statistically analyzed, and with the help of particularly all these altmetric tools, we have noticed they include the citation as the citation and publication count as the basis of calculation. Hence, therefore, this is the challenge of present day research to develop different types of variables, for instance, for H index and E index, and hence any particular tool cannot be describe the state of an article or state of a research completely. For instance, in this HE plane, we have said that there are two variables H and E, and to understand a particular research front or to develop any research front or research track, what is to be done? We have to find out the locus of articles. Locus means its path over the years. It may be this type, it may be straight away, or it may be small like this, and from these different type of curves we will be able to understand how any research pattern develops and how it advances. This is the locus under HE diagram, and this type of quantitative parameters can be developed under the results obtained from the output of these altmetric tools. So, thank you. This ends our today's discussion, and if you face any problem, you can post any question to the forum, or you can email me. The email address is given at the beginning slide. So, thank you.